Hello, this is Math 2231 coming to you from the College of DuPage during the summer of 2020. And the title of this lecture is Computing Indefinite Integrals and Solving Initial Value Problems. In the previous lecture, we started looking at indefinite integrals, and in that lecture we concentrated almost exclusively on notation, concepts, and properties of the indefinite integral. In this lecture we start thinking about how to actually compute these, and we start off with some basic indefinite integrals. The first integral that we'll look at is the integral of a power of x. So the indefinite integral of x raised to the nth power with respect to x is equal to x to the n plus 1 over n plus 1 plus c, and this formula holds for n not equaling minus 1. Now you should note that you can check this by taking the derivative of this side. So if we took the derivative of this side, we would get n plus 1, which would cancel with that denominator and have x to the n, and the derivative of the constant would be 0, so you see we get the integrand. So that is a good way for us to check with the derivative. And the way I would generally say this is to integrate x to the n, we add 1 to the exponent and divide by the new exponent and add plus c. Now n can't be minus 1 because that would mean we would be dividing by 0, and we'll care for that very soon. A special case of this formula, using a property we had before, was if we were integrating a constant k with respect to x. Well, we can jerk the k through the integral sign, and then we're integrating 1 dx. But 1 is the same thing as x to the 0, so we add 1 to the exponent, making it x, divided by the new exponent. It's still x. So you see, this is going to be the indefinite integral of k with respect to x is going to be kx plus c. Now you want to start making a list of these formulas, beginning with these first two that we have. The list will grow rapidly and should be committed to memory. You will be using these extensively in even this lecture. So let's remind ourselves of the trig functions. If we differentiate the cosine, we get the sine. But that means when we take the antiderivative of the sine of x dx, we get the negative of the cosine of x plus c. If we take the derivative of the sine of x, we get the cosine of x. So that means the indefinite integral of the cosine of x dx is equal to sine of x plus c. When we take the derivative of the tangent of x, we get the secant squared of x. That means the indefinite integral of the secant squared of x with respect to x is the tangent of x plus c. When we take the derivative of the secant of x, we get the secant of x times tangent of x. That means the indefinite integral of the secant of x, tangent of x with respect to x is equal to the secant of x plus c. When we take the derivative of the cotangent of x, we get the negative of the cosecant squared of x. That means when we take the indefinite integral of the cosecant squared of x with respect to x, we get negative cotangent of x plus c. Finally, on this page, when we take the derivative of the cosecant of x, we get the negative cosecant of x times the cotangent of x dx. That means when we take the indefinite integral of the cosecant of x times the cotangent of x dx, we get negative cosecant of x plus c. Other functions. We learned that if we take the derivative of e to the x, we get e to the x. That means that the indefinite integral of e to the x dx is equal to e to the x plus c. We learned that if we have a to the x divided by the natural logarithm of a to the x and take the derivative, we will get a to the x. So that means that the indefinite integral of a to the x dx is equal to a to the x over the natural logarithm of a plus c. We also learned that if you take the derivative of the absolute value of x, you will get 1 over x. That means that the indefinite integral of 1 over x dx is equal to the natural logarithm of the absolute value of x plus c. Yes, those absolute values sometimes matter. We also did things with inverse functions, hyperbolic functions, and so on and so forth. We learned that the derivative of the arctangent of x was 1 over x squared plus 1. That means that this indefinite integral is equal to the arctangent of x plus c. We learned that the derivative of the arcsine of x was equal to 1 over the square root of 1 minus x squared. That means that when we integrate the indefinite integral of 1 over square root of 1 minus x squared dx, we get the arcsine of x plus c. We also had these identities for the hyperbolic trig functions. And there are even more formulas, but this is sufficient for us to get started and actually calculate some of these. I hope you have been compiling your list. So now here's the problem I'm going to ask you to do, and actually it's not one problem, it is 6 problems. Here we use the properties and the formulas for indefinite integrals that we have to calculate these. You're to evaluate each of the following definite integrals. There are 6 different problems here, and you know what to do. You should do all 6. And check your answers by using the derivative before you tune into 31.1, the next video.